Yes. And now we will start the panel session. For the panel session, I have invited 3 speakers, as you hear, and also 3 panelists from various areas of the shipbuilding industry in Korea. So if I first give a short summary about what we hear today from 3 speakers, then Dr. Tae-ho Lee explained what the nuclear engineers are doing in Korea for the development of SMR to use in ship building. And also Patrick showed a brief introduction about the benefit and challenges that for the use of the nuclear energy in ship area. And also Dr. Jung explained about what are the regulatory issues and status for the deployment of nuclear ship in commercial scale. So I have invited 3 panelists for the panel session. So I would like to introduce Dr. Heesung Lee from Samsung Heavy Industry. He's working as in charge of the safety and environment analysis, and also the development of MSR in Korea. And Dr. Sang-min Park from HCD Korea Shipbuilding and Ocean Engineering. He's now working as the CTO there for in charge of the new technology development. Also, I have invited the Dr. Seol Han-sim from KRISO. He's in charge of the development of various types of ship there. So the way what I would like to proceed this panel session is that I will ask some questions about the 3 speakers that you hear, and then I will ask the other panelists to answer some questions, and then I'll invite 2 or 3 questions from the floor. Okay? So first, I would like to ask Dr. Lee about the what the issues in the commercialization of the nuclear ship in view of the nuclear engineering. So I think everybody will be very interested in that issue.
So I briefly talked about the SMR with my presentation. But in fact, whether you use water as a coolant or sodium or the gas as coolant, we actually have a very diverse array of nuclear reactors. And therefore, we have to think about what reactor would be most suitable for marine environment. And this requires a lot of extensive studies. So I suggested the molten salt reactor as a effective solution. But most of the nuclear reactors right now are based on the light water reactor technology. So again, it needs a lot of investigation. And also we have to fulfill several requirements, including the reduction of the fuel spent, as well as the modularization and environmental friendliness and so on. But I believe that the devil is in the more technical details. For example, like the controllability of operation, or how we can handle various kind of resistance in relation with the ship motion. And also the various components have to be reduced in size in order to have an effective commercialization. And also most of the reactors are for the land environment. So we have to think about how we can apply that to the unique marine environment and how we can ensure safety in that process. So this requires a lot of studies. And also together with the nuclear sector and the maritime sector, these 2 sectors have to be connected for effective development because the things will be very complicated. And also there will be a lot of requirements, especially in terms of the space and so on. And so I believe more cooperation has to be done between the nuclear sector and maritime sector. And as for regulations, the other speakers talked about that in detail, so I will just talk about technical aspects. So there are various technologies that now exist. So based on the operating conditions, we have to have technical challenges. And if we can have ample time and money, then of course we can embark on commercialization right away. But as for the practical challenges that we have to deal with, first of all, we can apply the marine conditions to the land-based design. And so with this design, we can do some demonstration, land-based, and then we can take that into the ocean, the marine environment. Then I think we will be able to have a more realistic commercialization with a safer option rather than developing and doing everything offshore. So again, I think that maybe we can start the onshore development first and apply that to the marine sector. I think that will be the way that we have to pursue.
이 박사님 감사합니다. 이 박사님은 뭐 해양의 특성을 원자로 설계에 반영하는 거, 그다음에 그 개념들을 또 실증하는 것이 중요하다 이렇게 말씀해 주셨습니다. Now I'm going to invite, I'm going to give some questions to Patrick and Dr. Jung. I mean, you have mentioned several challenges and issues for the deployment of the nuclear ship in commercial area. And there are many aspects, but what I would like to ask today is what should be done by the IMO or IAEA for the realization of the nuclear ship in industrial scale. Please, Patrick first.
Okay. Thank you, Dr. Lim. So I think Dr. Chung did a good job of surveying the landscape of regulations that exist today. When you read SOLAS Chapter 8, and when you think about any of the applications of regulations to nuclear energy that exist prior to very recent past, everything is focused on pressurized water reactors or light water reactors. Certainly, SOLAS Chapter 8 from 1974 needs a new look, and that is a responsibility of the IMO. We think at ABS that this spans beyond even simply nuclear energy related issues, but certainly that's first and foremost on the topic of our minds, SOLAS Chapter 8 revision, when we think about challenges, regulatory challenges for nuclear energy. There's another organization attached to the IMO called the World Nuclear Transport Institute, or WNTI, that pertains to some of the regulations around carrying nuclear material, not using nuclear material as propulsion. But that body is fairly active today on the topic of small modular reactors and the transport of HALEU, or the high-assay, low-enriched uranium fuels from places like France to places like the United States or Korea. And a lot of the regulatory drivers are happening there, and I think the IMO can take a look at the recommendations from WNTI to go take a look at SOLAS. And one other topic that I'd like to raise that we haven't really talked about, but that's very adjacent to regulatory, is insurance. When we think about and we look at the history of nuclear-powered vessels since the 1960s to today, they're government vessels. So they were self-insured, so to speak. They were warranted or guaranteed by the governments that owned them. As we look forward to a future where we have commercial shipping, tackling the challenge of insurability is going to be very, very important to make nuclear energy use in shipping a reality. And so as an adjacency to regulatory concerns, another topic, another area that our industry will certainly need to engage in with the P&I clubs and other insurance bodies that will have to figure out how they're going to make this work for shipping.
네.
So I would like to add some comment on that. that in IMO or in shipbuilding sector, so the IMO convention provides a very strong unified regulation to ensure the free navigation and sailing of ships across borders. However, the nuclear sector, each country has its own law, and mutual recognition of different countries is very difficult. But so if the nuclear power ships cannot navigate freely, then it's not commercially beneficial. And therefore, IAEA, I believe, should establish a unified regulation, just like IMO, so that they can be implemented by all countries to ensure free navigation. Thank you very much.
If you allow me to make a short summary, I mean, I'm going to expect very comprehensive and integrated activities from the IMO to resolve all these regulatory issues, including the issues in nuclear material transport and also in the insurance. And so I think Dr. Jung is giving an idea to the nuclear engineers about what we should work together with the IEA to for the realization of the commercial ships, nuclear ships. So now I'm going to invite 3 experts in the ship engineering. So, well, actually we are talking about the use of nuclear energy. So I'm a nuclear engineer, and Dr. Lee is also a nuclear engineer. So I think you are the expert in the shipbuilding and ship engineering. I think you have some messages that is important for the nuclear engineers, for the realization of the commercial nuclear ship. So would you make a short remark one by one? And if you feel my introduction to you was too short, then maybe you can add some word about yourself.
Very nice to meet you all. I'm Lee Heesung of Samsung Heavy Industries. In the nuclear industry, the marine application, we have received a lot of questions, and we have been very active in interactions as to that topic. But it's been only 1 or 2 years since we started this kind of conversation, and the national policy project has just begun. So we need more time to get to know each other, the shipbuilding industry and the nuclear industry and the maritime industry. And the area of cooperation, I hope to see, to take some examples. The first is the development in developing reactor itself. I think, well, there should be an in-depth understanding of the marine environment, and there should be an active discussion as to that. In 3 to 4 years' time, we will not be able to see fully commercialized nuclear vessel. That is why we have to take a long-term perspective. So rather than focusing only on currently available vessel type and the vessel model, they might not be of any use at all when we have the technology mature enough for commercialization. So we have to have a concrete discussion as to which vessel type and which vessel shape we will go for this nuclear vessel. Only then we can talk about the speed, above 20 knots or below 20 knots, or even above 30 knots, and so on. So we need to be engaged in more active discussion and conversation. And the second point I'd like to talk about is a propulsion system. So we may run a totally different propulsion system, so not relying on the propeller scheme anymore. That is why we need to be quite active in our discussion so that we can be agile in adapting ourselves to any technological advances. And then we can move on to which batch can be applied into the reactor development. And the last part is about operation. So who will control the SMR? We are not talking about any human operation. Many people are talking about automated remote control of the SMR. How much we can be flexible and open to this idea? Well, this should be further discussed as well.
So next, Dr. Park, please.
Yes, so good morning. I am Park Sang-min, Research Director of Ph.D. Korea Shipbuilding and Offshore Engineering. So we are the subsidiary of the HHI that support the shipbuilding and offshore engineering. So our major goal is to develop environment-friendly ships, and recently we focus on developing nuclear power ships. I have been in the company for about 20 years, and mainly in the shipbuilding and the marine plant. I was engaged in some novel technology development, and I had opportunity to work with many colleagues who developed very pioneering technologies. In other words, our research institute focuses on future-oriented technology rather than supporting the existing operation. So I think that it really gives me a lot of luck. So in the past, as for the LNG-powered ships, it was based on the steam engine, but then with the advent of 2000, TFD or LNG power ships, LPG power ships started to emerge, and recently replaced by methane and ethanol. So these were sort of the future technologies at the time, but now it has become the standard technology. Even the ammonia propulsion ships, we now take orders for that. And also for example, like the air lubricant component. When I first joined the company, I thought that it's just an absurd. This is to spray the air droplets to reduce the resistance. So at the time, I thought it's just absurd, but now it has become a standard technology for LNG power ships. So with these technological advances, the equipment manufacturers are also changing, and the hegemony or the so-called like strong players are also all have been changed. So in the past, Japanese players played a very pivotal, strong role, but now they're replaced by many other companies. And I believe that the similar advances and changes will take place in the nuclear sector as well. So later, I will be able to talk more about the challenges and opportunities in the future, but I believe that the nuclear power ships could be a reality, and it has a lot of potential, as well as many advantages. Shipbuilding industry enjoyed a strong heydays recently, but in reality, in fact, the Chinese shipbuilding industry is rising very fast, posing a severe threat to Korean players. And so if the current status continues for a few years, then I think not just in terms of the price competitiveness, even for the technological competitiveness, Korea will be outpaced by Chinese companies. And therefore, if we can develop more effective, cheaper system, and if we could identify such opportunities, then we really have to push forward with these opportunities. And I believe this is something that the researchers and R&D department should do. And the Patrick Lyon talked about the floating SMR-based technology, as well as the hydrogen-based ships and so on. And for shipbuilders, I believe they have very high expectation for the nuclear propulsion ships in terms of the technology approval. Yes, some people are saying that the floating type is better, but just for the barge supply, the shipbuilders will not disrupt their existing manufacturing process, and also the demand would be pretty minimal. And therefore, rather than the floating structure, they are more interested in the propulsion ships. And I believe if the propulsion ships could be powered by nuclear technology, then this could create huge market opportunities for many shipbuilders. So that's why they're interested. And also with the advice from Patrick Lyon, last month I went to Washington, and I was able to serve as a discussant for the Marine Safety Energy Forum. At the time, I felt that there are strong push for the commercialization of the nuclear power ships, mainly driven by the UK and the US companies. And in fact, things are progressing much faster than what we experienced in Korea. So I thought that the nuclear-powered propulsion ships or the merchant ships is not a distant reality. Rather, it could be a reality soon. And especially the fourth generation SMR enhances the probability for commercialization. And also, I heard about the various plans of various companies. And also the participants in that forum expressed their interest for cooperation with the Korea Power, as well as the Korean shipbuilders. And for the reactor type that we develop in Korea, I think that foreign participants are not really interested in, but they showed strong respect for Korea's engineering technology, ship engineering. And so maybe we can mount the reactors developed by UK or the US company, and which is very safe based on their military experiences. And we can mount these reactors onto Korean ships. So I think that could be the very realistic solution for commercialization. And eventually, I believe that the ship owners have to accept this technology in order to see this vessel a reality. So we have to develop the reactor type that can be acceptable for ship owners, and we have to develop technologies acceptable to the ship owners. So again, this requires the strong cooperation with other nations as well as the registry. And this is one of the main reasons that we decided to invest in TerraPower, a US company. And SMR is very safe and compact in size. And if you take that, bear the possibility of the marine application in mind, then you shouldn't just compare it versus the onshore facility. Rather, compared to the ammonia-based propulsion ships, we have to prove and demonstrate the superior safety of the SMR technology. Because the onshore, the safety assessment is based on the EPG concept. So, for example, like the light water reactor, it was the tens of meters, but then the SMR can secure the guarantee the safety for hundreds of meters of range. However, the offshore ships, we have to think about the crew who are isolated in the marine environment, and therefore onboard should be safe enough. And this means that the SMR assessment range should be within meters. And if the pressurized reactor cannot achieve that, then it's not suitable for marine application. And in the sense, we have to make the radical decision to discard the technology and develop a new technology. And that's why I believe we have to be interested in the fourth generation reactor technology. And also, as for the economic feasibility, the methane-based or ethanol-based ships, they are now drawing a lot of attention, and it's about $20 billion to construct the large ships, and its OPEX, green methanol, it's about $100 million. So if it's in operation for 25 years, then it will cost about 3 trillion won. And in fact, the initial capex is less than 10%. Then what about the nuclear-powered ships? If the entire lifespan cost is less than 1 trillion won, then ship owner will find it very attractive. And also with the 80 megawatt propulsion system and also the secondary electric system, if we could achieve like $600 to $700 million, then that could be a very attractive price for ship owners. So this is something that we have to target, and also we have to ensure the EPG-based safety. So these are something that we have to bear in mind in developing and realizing our vision of the nuclear-powered ships. And with that, thank you very much.
Thank you very much for such an elaborate and insightful comment, Dr. Seo. Very nice to meet you all. I'm Seol Han-shin from Korea Research Institute of Ships and Ocean Engineering. SMR fuel, SMR powered vessel. In the epilogue session last year, I delivered my presentation on SMR, and this year we have this full session on SMR. I'm very honored and privileged to be part of this SMR, first ever SMR session. So I would like to thank the organizer for such an arrangement. Many things covered by 3 presenters as well as 2 panelists. Well, that's what I have in mind. And in order for the swift commercialization of SMRs, there are various considerations we have to take into account. And rather than repeating what has been already addressed, I would like to share with you the thing other than that. As mentioned by many people, SMR does not emit greenhouse gases, and it has high energy density. So this would be a good vessel fuel to meet the requirements set by the IMO. And methanol and ammonia, these are also no carbon energy sources, but from the perspective of energy density, but I believe SMR will be the mainstream. And in Korea, various reactor types are being developed, and many people here are taking part in the relevant project in Korea. So with Korea's advanced nuclear technology, I believe SMR will come into the market sooner or later. And what I'd like to touch upon today is not just the SMR, but also from the perspective of the vessel which incorporate the SMR, there are several considerations. That's what I'd like to talk about today. And this has also extensively covered by other presenters. But since the development of the SMR, existing vessels to replace the existing engines with the SMR does mean that the vessels can operate normally as before. So in order for the design and operation of such a vessel, there are some considerations that you have to take into account in advance. First would be the acceptance of the public and economic feasibility, the safety and economic feasibility. And for the design and operation of a nuclear-powered vessel, we need to have rules and standards. And IMO SOLAS would be one of the examples here. And the various domestic regulations and rules governing the nuclear-powered vessels, but they are mostly based on the light water reactor-based vessels. This does not include the 4th generation of the reactors or SMRs. So in the design and the operation of the nuclear-powered vessels and SMR incorporating vessels, we first need to have the standard and rules and regulations. The US and the UK are focusing on this area regulatory field. And as mentioned by Dr. Chung, vessels navigate across the ocean, stopping at many nations. So that is why we need international coordination related to the standardization of the rules and regulations. And I expect many of you to make significant contribution as to this. We have a nuclear designer and various experts in the shipbuilding industry as well. And my point here is that our coordination and cooperation is of greatest importance for the swift commercialization of SMR. Thank you. Thank you, Dr. Sar. I cannot say that I have the full and accurate understanding of all 3 comments, but for the audience, let me summarize. And for the marine application of the SMR, there are various things we have to consider. The first is the understanding of the future, and those who are in the nuclear industry should have a better understanding of the marine and maritime industry. And we are currently focusing only on propulsion, but we also have to consider other aspects as well. And since vessels navigate constantly, so the autonomous navigation as well as the engine development should be our focus. And we are talking about floating type and various other technological applications. But we should focus more on the vessels, nuclear-powered vessel. And in order for the swift commercialization, we should first do some pilot run or a smaller scale covering a certain route. And ship owners, since they are the final stakeholders, should be attracted into adopting the SMR. So economic feasibility, EPG, or safety-related ones, what should be done has been highlighted. About 1 trillion Korean won. If we can go for 1 trillion Korean won for the SMR incorporating vessel, that will be attractive enough for ship owners. Since nuclear power has high energy density, it is quite promising. But in order for us to realize that promise, there should be a strong and solid rules and regulations as well as the standard. That is why the cooperation between the maritime industry and the nuclear industry is of greatest importance. Then I'd like to open the floor for further questions. If you have any questions, then the floor is yours.
네, 마이크 전달해 주시죠.
So, World Ocean Forum. In the World Ocean Forum, we have talked a lot about nationwide, let's say, technology development and application. But as a Pusan citizens, I actually want to zoom in our focus more on our locality. So Pusan is somehow underdeveloped, and economic development has become very sluggish. So, in fact, the shipbuilding initially began in Pusan, but now the other cities are having more dominance in this industry. But I believe that SMR could be another engine to promote economic revitalization of Pusan. So just like the Hanjin heavy industry, what they did, if we don't have the land space enough, then maybe we can have a floating type for SMR ships, and we can grow this industry so that it can serve as an engine, another locomotive to promote Busan's economic recovery. So how can we make Pusan a hub for the nuclear-powered ships? Do you have any idea for that? Rather than answering the question, I first want to ask you to introduce your name and your affiliation. I am professor of the Pusan University of Foreign Studies. So you talked about the Pusan's development and what kind of what we need to do to promote SMR as a hub industry for Pusan.
Okay, please.
Well, I don't live in Busan. Maybe that's obvious. But I think something that's happening around the world that may be very applicable here is the initiation and the stand-up of green corridors for shipping. Busan is known for its amazing port facilities, and what's happening, at last check, perhaps Dr. Chung knows, I think there were about 26, but a few dozen of these green corridors, and they were primarily driven around the availability of the unique bunkering fuel, methanol, etc., that are starting to emerge And certainly I think that's a wonderful model for nuclear transport between ports. It helps facilitate the regulatory challenge. So if you have a green corridor between, say, the port of Busan and Los Angeles, those two nations agree on the licensing for the reactor, United States and Korea. The green corridor will support shipping between those two ports, and then the nuclear-powered ships can be supported by those ports with an infrastructure investment by them for reverse cold ironing, for instance, or the other support necessary for the vessel. So I think what I would offer is for Busan to look to the port as an opportunity to really grow the connection with the nuclear solution for shipping.
Thank you, Patrick. So, 박사님은
Does that answer your question? I'd like to know. I'd like to add on to that. I think your question was the question I received at the conference in Washington last month. It was about nuclear yard. A nuclear-powered vessel, if that is built, there is a safety-related equipment burden on the part of the yard. And my answer was that the existing nuclear power plants located alongside the coast can be an opportunity. That was my answer. For example, even if a shipyard build a nuclear powered vessel, well, they do not handle the reactor itself. They create the container of that reactor. There is another place which will incorporate this reactor into the vessel. And most of the nuclear power plants are located alongside the coast. And so I believe the commissioning and decommissioning can be done in Korea. And if there is any city which can perform such a task, then the city can enjoy a huge benefit. And the KOERI nuclear power plant located in Kijang, which is right next to Busan, if they can create such a value chain and supply chain, so the road can be unloaded onto the vessel in Kijang, that means another source of great revenue for the city, the entire city metropolitan area of Busan. And since shipyard cannot handle the fuel rod itself, this is an indispensable part and element in the supply chain. That is why the nuclear power plant hosting cities can enjoy and capture this benefit and opportunity.
Any other idea? Yes, I would like to also add my idea. So your question, I think, is actually crucial for host organization, I guess. And this is something that I also put a lot of thought into, because we have to have some region or spaces as a hub for nuclear development. And we have to think about what kind of benefits they can get. And I believe establishing nuclear facility by and of itself may not be a benefit. What's important is to establish an ecosystem as well as the basic facilities. And for the marine nuclear power, I believe that Busan does have a great potential and expertise for engineering. So this is something that Busan can work on. And adding to that, for the nuclear-related facilities, as I said earlier, I think that these could be controlled in a remote fashion or with the autonomous system. And I believe this system could be developed effectively by ports that are engaged in operations. So if Busan can make preparation for future demands, I'm sure that Busan will have strong competitiveness. In our research institute, we also do some concept design and basic research for nuclear power ships. And regarding your question, responding to your question, maybe we can think about some business models. For example, the nuclear power ships. It will be berthing, or when it wait to enter and arrive. If SMR is not used for ship operation, then maybe the electricity produced from the SMR can be stored in ESS or be used to produce hydrogen. So using the marine facilities that Pusan has, maybe you can develop various business models where you can effectively utilize SMR. And if these are developed, then I believe this could also boost the local economy and expand the relevant facilities.
Please use the microphone for translation. I'm not an engineer. I'm not a technology major. I have an idea and I'd like to share with you. We use batteries for cars these days, and those batteries are replaced on a regular basis. And if a vessel stops at Pusan port, then we can produce the SMR. We can be the replacing station for those SMR incorporating vessels, and we can do the repair. And if it can be rechargeable, then we can have this recharging station. So the city of Pusan can serve as a general hospital for SMR incorporating nuclear-powered vessels. The final checkup place and the supplier, major supplier of parts and components for nuclear-powered vessels. I believe this presents a genuine opportunity for Pusan. To that end, we need to be pioneer. The Pusan port needs to have the full-fledged system and full package, from the raw materials all the way to the parts and components and the system. Everything about ships should be covered by the city of Pusan and by especially Pusan port. And as collaborators and contributors in this platform, I would like to ask you to form a task force to bring forward the advent of the net zero society. Thank you. Thank you very much for your comment. So before asking a question, you already had the answer in mind. So to summarize, Pusan has such a large-scale trade port, international port, and since Pusan has existing infrastructure for shipbuilding as well, Pusan can be the pioneer, and Pusan can spearhead this nuclear industry in this new era. So SMR or the nuclear-powered vessel will present a genuine opportunity for Pusan. I'd like to turn to the next question from the floor. Good morning. I'm Lee Seung-wook from KEPCO, Korea Electronic Technology. My company designs nuclear power plant, and my company also is developing SMR and is involved in various projects. And we are collaborating with the shipbuilding industry as well. We are in the initial stage of the discussion. As you know too well, nuclear power has been in the public domain so far, and most of the projects have been taking place in the public sector, and the shipbuilding has been the private industry, the private sector, and so there is such a gap between the public and private sector, and the nuclear industry and the shipbuilding industry seem to have different views and perspectives toward this concept of SMR and SMR incorporation. And this item and this business opportunity is very important for our future. So I'd like to know whether you have any idea for the industry-to-industry cooperation model, how we can facilitate the cooperation between the two different industries, the two different sectors. So the question was presented from the nuclear field or the person from the nuclear industry. So I'd like to turn to anyone from non-nuclear industry. Who would you like to address the question? So to my understanding, your question is how we can build a collaboration structure between the two different industries for efficient and effective collaboration. Although I'm not a nuclear expert, based on my thoughts, I have given to this area the marine application and the land application of the nuclear power and the reactor are totally different. That is why we definitely need the collaboration and cooperation, not just in terms of technology. Shipbuilding or the land-based application, there are two different areas, completely different. So in developing SMR, since KAERI is the most advanced agency, and as for shipbuilding, current shipbuilders are most advanced in terms of technology. At the national level, there should be a collaboration structure between the two industries. In addition to that, there are things to be tackled in addition to the technological cooperation, for example, regulation. And the key in regulation would be safety and rules. So classification in the class society and the nuclear safety-related public institute in Korea can work together in order to set and define roles and responsibilities. In the initial stage, I think, well, my answer is be too high level, but I believe we need to collaborate further.
I just want to make some brief comment. So I would like to give you some simple example. That, for example, like with the high temperature gas, many companies are paying attention to developing the fuel with these substances, and there is a growing interest among private players. So this year, we established a consultative body for the development of this fuel technology. And we don't do project, we don't start project right away, but because it's difficult to develop this kind of technology. So we wanted to first create a consultative body as a platform to discuss and share their interest, and also come up with some roadmaps for technological development. And once this organization becomes mature, then maybe one of the participating companies can start and initiate the project and the actual efforts for technology development. So I think this could be a great model. So we can establish a non-binding sort of consultative framework where industries and companies can gather and share their interests and understanding. And once it becomes mature enough, then maybe they can start some projects. So this is my idea. This is a bit off from the question, but I want to make this comment. That is for the propulsion system. So if it is replaced with the nuclear technology, that means that all the components that are mounted on the ships, so the main propulsion system, as well as the engine, will be replaced with new technology. So this could pose a threat to European engine makers. And I believe that they will strongly resist the idea of developing nuclear technology for marine application. But they are the ones who have strong influences in IMO decision-making process. And therefore, our vision and what we discussed today will not be proceeded smoothly. Rather, there will be a very, very strong resistance from these established interests And so I think sharing information to induce gradual change is very important. For the shipbuilding sector, the nuclear energy technology is not just about converting to more environment-friendly ships. Rather, it involves the shaking of the existing landscape with the dominant European players. And I think the shift will be made to the power will shift to the U.S. players with the emergence of the nuclear technology. So again, if we want to establish that kind of consultative body, then not just the friendly the partners, I believe the established interest, the European makers who will resist in this movement should also join. So summarizing what we have discussed so far, we have talked about the regulation and also for the ship industry, nuclear industry, and also the regulators. They should all work together. And also the market, for the market, we have to have a more loose consultative organization in order to promote communication and partnership and cooperation. And also there are people who are for nuclear energy development, but also who are strongly against this technology development. And therefore we have to embrace both sides in order to ensure the real progress.
There may be more questions that I would like to be discussed here, but time is running. So I think I would like to close this session. So today, I think we found that what are the challenges and benefits that we can enjoy and face in the commercialization of nuclear ship in the marine area. And also we found what we should do together for the realization of them. And also we found that the Pusan is a good potential to become a pioneer in commercialization of the nuclear ship. So it was my great pleasure to enjoy those times with all the participants and all the speakers and as well as panelists. And I hope and to see the further improvement in this area. And so to realize that, let's go together. Let's make the step together. Thank you very much, everybody.
큰 박수 부탁드립니다.
Please give them another round of big hand. Thank you very much, our presenters and panelists. This concludes this session. And please stay on the stage for a photo session. Thank you.
We'll have a commemorative photo session together. Please come forward, and then let's take a photo together. 나눠드리고 있는 강판을 앞쪽으로 펼쳐서 함께 촬영 진행해 주시면 감사할 것 같습니다. 무대 중앙 쪽으로 모이셔서 기념 촬영 진행하겠습니다. 네, 진심으로 감사드립니다. Once again, thank you so much for the wonderful session. 다시 한번 큰 박수 보내드립니다. 진심으로 감사드립니다. This brings us to the end of the SMR shipping session. 진심으로 감사드립니다. 이것으로 SMR 선박 세션은 모두 마무리하고요. 오후 1시 30분부터는요. 이곳에서 조선 해양 세션이 시작될 예정입니다. 2050 탄소 중립 시대 오션 모빌리티 및 해양 디지털 솔루션 기술의 대전환을 주제로 이곳에서 1시 30분에 다시 세션이 시작되니 많은 관심 부탁드립니다. 잠시 후에 또 뵙겠습니다. 즐거운 오찬 시간 되십시오.